Humidity. Should you add it? Hit the music. Hello and welcome to the Adding Energy Podcast, a podcast about energy usage, energy efficiency, and energy issues. I'm your host, Brian McLean, but you can call me Sir. When we talk about humidity, we're talking about the moisture in the air. Engineers like to think about the moisture in the air as in the pounds of water per pound of air, and that's not a big number. Normally it's like 0.00 or 0.01, and because that doesn't really meet the normal engineer rules for a number where like 1 and 0 is small and 100 is big. We like to change and not use pounds per pound. We use grains per pound. And with grains per pound, 1 grain is 1/7,000th of a pound. If you're into projectiles, you might know that. And so then you get at the point where like 15 grains per pound is pretty dry, 40 grains per pound is pretty wet. So the issue that humans have is that we actually don't care about the grains per pound. We care about how much more moisture the air can take. So we normally talk about humidity in terms of relative humidity. Now, if we're talking about air and that specific air can hold 40 grains per pound of moisture, and if it's at 20 grains per pound of moisture, then we say it's 50% relative humidity. Now, 50% relative humidity is pretty comfortable. In fact, from like about 30 to 60% relative humidity is pretty comfortable. You're able to cool yourself off without being at the extremes where you're kind of get the higher humidities. You're kind of either cold and clammy or hot and sweaty. Lower, drier temperatures. You're either like breathing can get irritated and things like that. So we like to kind of be in that sweet spot. Now, the problems you have with humidity is it's proportional to the temperature of the air. So if you take a lump of air and you reduce its temperature, not changing the amount of water, not changing the amount of air, just reduce the temperature. As you reduce the temperature, the air becomes more and more saturated because it can hold less water total, and so it becomes higher relative humidity as you cool the air down. If you go back and take that same lump of air and then heat it up, it becomes drier or less relatively humid because as you increase the temperature, it can hold more water. So that's a quick synopsis. For houses and residences, normally if I'm talking about adding humidity to a space, I quickly end up in like 2 types of systems. I'd say about 9 out of 10 times when I'm talking to people about humidifiers or humidification, we're dealing with 2 types of systems. Number 1 is like wood-fired. Wood stove, wood pellets, fireplace, something burning a solid fuel. And the reason that you have that is a couple. And so the first one is you actually are taking humidity and probably sending it up the chimney. Because wood and solid fuel burning appliances are not very sophisticated, they usually take the air from the space and use that for combustion. So when you take the air in your living room or whatever room your wood stove or wood fireplace is in, you take that air in that space, you put it into your fire, and then send that up the chimney. That'll take the humidity out of the air. Now, if you're running your fireplace, it's probably cold outside. Probably really cold outside. So when you replace that air that went up your chimney with air from the outside, whether it's sneaking through cracks or doors or even things that were intentionally put there to bring more air into the house, that air coming from the outside might be humid at the temperature it's at, but you're going to heat it up from 30 to 60, 70, and that 40-degree temperature rise is going to make that air dry. And then in that room that you're in, the living room with the fireplace in it, it's probably going to get even warmer and get even drier. So number 1, you're sending your moisture up the chimney. Number 2, the air, once you bring it in the house, you're heating it up and drying it out. Now, if you have a wood stove or a wood fireplace, you can add humidity to the air with something as simple as a kettle or a pot on your wood stove. If you're doing that, don't boil it dry. Boil it down maybe 30%, fill it up once or twice. And about every third or fourth time you fill it, dump it all out, wash it out, fill it back up and do it again. Because as you boil off the water, whatever's in your water that wasn't water is there stronger. So salts, minerals, whatever. The other type of system that we talk about humidification with is warm air furnaces. If you have a warm air furnace, you're taking air that is presumably comfortable, and you're not replacing it with outside air as much as you're taking air that's in your house. You're going to take it from 60, 70 degrees to 90 to 100 degrees. So even if it's 50% relative humidity at 60, 70 degrees, it's going to quickly dry out and you're going to be in 20 or 30%. And if it was dry to begin with, it's going to get even drier. So if your air is at 30% at 60 degrees, it's going to be at like 10% at 100 degrees. Not only that, it's moving, right? You have a warm air furnace, it's blowing air around your house in about every 18 minutes, I think, in your average house. It's changing over all the air in the house. So you're blowing hot air over everybody and you're continually replacing it. That's a great way to make your air feel really dry. So when you start adding humidity to it, it's not that it's lost its humidity, it's just that at the higher temperature it's drier. So I like people to be careful with adding humidity with warm air furnaces. Now, with a warm air furnace, there's a couple ways to do it. I would recommend, if you're going to add humidity with any of these systems, that the first thing you would do is go to a store with aisles and stuff on shelves and buy something that says humidifier on the side of it. It's going to run you normally like $50 to $100. With that $50 to $100 you're going to spend, you're going to get to learn a lot about you, a lot about the humidity you like, and the things that get complicated with having humidification in your house. So when you buy the thing at the store, it's going to have usually a media that sits in a little tray of water. It's going to have a jug of water that you fill up that holds usually about 2.5 gallons. And if you can fill that thing once a day, and that's enough to keep your house at a good humidity, then that's probably the answer you want to stick with. Adding 2.5 gallons a day on your cold week. Now, it doesn't have to be some extreme cold day. It doesn't have to be, days when it's 50 degrees outside. You want your coldest 2, 3, 4 weeks of the year, that one bucket a day, one refill a day is about all it takes. That's a reasonable amount of water. 10 pounds of water into your air. That's not a crazy amount to add over 24 hours. It's the other things that you get to learn about when you do that is you get to learn about your water. When you start running the system and evaporating a lot of things out of the water, whatever doesn't evaporate is going to stay in that pan, tray, filter, media, whatever you got going on. So you're going to learn that you probably need to treat your water with an additive chemicals, sometimes filtration. You also learn if there's like bacteria growing in your water. You'll learn if there's lots of salt, minerals, calcium in your water, hardness, sometimes we talk about it. And then you're going to learn about the things in the air that collect on that media, filter, mesh stuff that you're blowing all this over. Learning all that about you and your water in your home, it's a good way to learn it. So the other thing you buy when you buy that specific device to add humidity to your house, either on that or as part of something else, buy a sensor that will tell you the relative humidity of the room. I would try to find the lowest acceptable humidification that works for you and the people who live in your house. When you're adding humidity, I don't want it just to be, well, I put a sensor in, or I bought this thing, or my Wi-Fi enabled thermostat tells me that my house is only 20, 30, 40% RH. I expect that if you're having this issue, that you're actually dealing with a problem. Now, there's lots of problems caused by low humidity. Eye irritation, nose, throat irritation, dry skin, bloody noses, all those things don't do well because all those surfaces of your body are supposed to be somewhat moist. Now, if you have one of those symptoms, do a little research, try some stuff. Hand lotion, eye drops. If it was just one or the other, then I would say you try to treat that symptom. But if it's pervasive, if it's continuous, and if you can kind of predict when it's going to happen by how the air feels, yeah, go ahead. Look into a humidifier. Try to figure out what humidity you like. I would try to stay 35% under that. Depending on who you are and where you live and where you're measuring, sometimes it's not totally accurate for the whole massive house. You also, if you have a dehumidifier, you don't want to be fighting these out so that when the upstairs is getting humidified, eventually that air settles down, collects in the basement, cools off a little bit, and now your dehumidifier is running in your basement, removing the air that you just put into it, removing the water from the air you just put in it. You don't want your humidifier and your dehumidifier fighting it out. So you don't want to be blowing warm, moist air throughout the house, having that warm, moist air cool down, settle down to the basement, where your dehumidifier is removing the water you just put back into the air. So you buy your individual one, you're adding humidity to your air, you've learned about your water, you're doing this, you've learned that it takes more than 2.5 gallons a day. A buddy of mine called and was asking me all these questions, and he got that whole sermon before he got to the point of, yeah, I have one, I'm going over 10 gallons of water a day into my humidifier, basically every day, because we're getting nosebleeds and irritation, throat, and stuff like that. I said, oh, all right, I can believe that. And so my recommendation to him was, all right, go ahead and look at a humidifier. He has a warm air furnace. He had already looked at some humidifiers, and he knew a name brand one that he liked, and it's actually one I'm familiar with, and I liked it too. So I'd like to tell you about a couple types of humidifiers, and then the two kind of options you have for installing them. So the first one, almost never used in residences, and I wouldn't necessarily recommend it for a residence, but you can use direct or indirect steam humidifier. So you either have something that's making steam or something that's using high temperature to make steam. And then you add steam to your airflow. Now, adding steam to your airflow is good for a lot of reasons, because if you're adding humidity to the air, it's normally when you're also looking to add heat, like winter, cold outside times. The other thing with it is when you're adding steam, you can add a lot of steam to air, and that's a great way to add a lot of moisture. So that's good for those two reasons. There's a lot of reasons why you use steam in things like hospitals, because you kill all the bacteria in it. And by boiling it off, you're not making more and more concentrated stuff. You're adding, sterilized water to your airstream. It's also the most energy intensive way to add humidity. So it's a lot of energy to add steam, or to make steam to add humidity to your air. So fairly uncommon in residences. In residences, you can deal with ultrasonic. I haven't seen ultrasonic in a permanent solution per se. It's pretty common in things that you sit on the floor. If you have a essential oil evaporator, that's an ultrasonic thing. You excite the water to create droplets, cloud, fog, those types of things, and you get a little stream of mist that comes out. Those are fine. What happens is the water, you make droplets, you make clouds. Those clouds come out, it evaporates into the air, cools the air slightly, and generally that's a pretty energy efficient way to add a little bit of moisture to your air. Some of the things that are kind of nice about that, because you're making a stream of drops, you're not having as much of the evaporation and bacteria growth that you kind of get on some of these media and filters. But the media and filters, they figured that out pretty good. So it's a lot easier to have those and replace those. And they tend to be more effective at having like longer run times. Ultrasonics can sometimes make a little bit of noise depending on the technologies. And because they're exciting the water, you do tend to get like that little bit of like calcium or mineral crusting in a bunch of different places where you can avoid that showing up on the permanent parts of the evaporative media systems. So the next type, evaporative media. So for those, you blow your air across, over, or through a media, and that media is wet, and so as the air goes through, it evaporates the moisture or the water off that media. Yes, the minerals then are in the media, but for the most part, that media that you have, that honeycomb, the foam, whatever it is, you throw away every few months or once a year or whatever. And that's a pretty good way to do it. Now, depending upon the amount of particulate you have in your air, sometimes you want to do it a little faster. If you have really hard water, you probably do it a little faster. If you have a lot of bacteria in your water, you probably do it a little faster. And it's good to do this with the little one that you plug into the wall and fill up every day, because you're touching that every day, so you're looking at it and you're seeing how bad it's getting. Once you get one that just slaps on a duct, it's going to be a lot harder to take a look at, or it's going to be a lot less necessary to take a look at. So, most of those, if not all of those, involve a media and a permanent connection to a water system, permanently installed in a duct, and then a whole bunch of bizarre controllers to try to decide when it's appropriate to add humidity to the space. So, number one, they're not generically for the faint of heart. There's a lot of questions as to whether you run it all the time your unit runs, or whether you have, when the unit's running, this checks to see what the humidity of the air is. If you want it to humidify the air when your space doesn't necessarily need heat, that's going to be some tricky controls. So there's a lot of things to look in as far as that. Talk with your vendor, supplier, installer to get a bunch of information on that and find out how it's supposed to work before you buy it. If they can't explain it to you, ask them for the guy that sells it to them. And eventually, even if you got to talk to the guy who works at El Evaporator Company, they will find someone who can explain to you how it's going to change your furnace run and how it's going to change your house controls. So, as far as the actual installation, there's kind of two thoughts. One thought is the manufacturer's thought. The other thought is the installer's thought. The manufacturer's thought is usually that you put the humidifier on the supply side of your furnace. So after it's gone through the filter, after it's gone through the heat exchanger and added heat to the space and through the fan, it then goes past their humidifier. They like this for a bunch of reasons. Number one, they like it because the air that's going past it has been filtered, so it's less dusty, and you don't get as much stuff stuck in your humidifier. The next reason they like it is because the air is moving. It's moving good. Usually nice high velocities, which helps with evaporation. It's also hot. Hot air helps with evaporation because it will be drier than the air that was not heated through the heat exchanger. So it'll have the ability to take a lot more moisture. And if you're looking at the rating of the humidifier and how many pounds per hour of water it can add to the air, you're going to have bigger numbers on the supply side of your furnace. A few things that are tricky about that. Normally the supply side of your furnace is a plenum, and that plenum doesn't necessarily have great airflow. So it's going to be hard to find a place to put it where there is a lot of air moving past it. You can get dead spots in plenums, so you kind of want to put it in a plenum so that the air goes past it and then down a trunk or down a branch, but you want it to go down all the branches with the warm, moist air. So finding a great spot is a little tricky. There's also not normally a lot of room left on plenums once they're installed and attached to all your ductwork. So that can also be slightly problematic for installing. The other thing is that relative to the pressure in your house, the pressure in your duct is about 2 inches of water column, one like tenth of a psi, and that's actually 4 times more than the pressure difference between your return and the air around it. So it's higher pressure, and if you install it poorly, the air is going to leak out of the duct around your humidifier. A lot of times they'll have a backing plate. It's just a little tricky to install that backing plate and then attach the humidifier to it. They normally give you a little gasket and some of that stuff. Whereas on the return, tends not to be as big or as visible an issue or a concern. The other thing is that the manufacturers will also like warm water. Now they like warm water because it's easier to evaporate the warm water, and that warm water can have better properties in a lot of ways than cold water. But what are you doing to make sure that the water showing up at your humidifier is actually warm? Now, if your furnace is right next to your water heater, then you can probably do that. That's probably pretty easy. But if you needed 20 feet of tubing between your water heater or your hot water line and your humidifier, by the time most of that water gets there, it's going to be at best room temperature. So hot water probably doesn't make a huge difference in a lot of terms. A lot of times they'd also like a filter, depending on where the water's coming from or how bad your water is. Sometimes a carbon filter to take out particulate and chlorine. Sometimes just a media filter for particulate. You could use softened water that'll have salt in it, but it won't have as much total dissolved solids. There's a lot of those types of things you can get into. Depending on what you learn from having the humidifier sitting on the floor, you might care more or less about those. Again, with all these things, if the person you're talking to can't explain it to them, ask for the person they're getting their stuff from. So the installer answer is to install your humidifier on the return. Now, there's a bunch of things here I kind of like. Number one, I think that a lot of people tend to over humidify, and it's going to be a lot harder to over humidify on your return than on the supply. Number one, because the air is colder. So it's going to be harder to evaporate air into 60, 65 degree air that's coming back to your furnace than it is at the 80, 90, 100 degree air leaving your furnace. So that's a good thing. The bad thing is that there's no filter before your return. The filter is where your return usually connects to your furnace. Another thing, if you're an installer, that you like is your return is usually just a box that's metal, and if you drip off your humidifier onto the box that's metal, that you might get a little rust or a little puddle that usually evaporates because the air's dry. Whereas if it's on the outlet of the furnace and it's like an upblast furnace, which is a very common style of furnace, you could be dripping down onto the electrics, the fan, and the parts of your furnace. That's normally when this thing is 8, 9, 10 years old and the stuff doesn't go back together quite as good as it did the first time. But that can happen. It also can happen if you never replace your media like you're supposed to, and instead of dripping onto paper or sponge, you're dripping onto this weird salt crystal mass. So that's another thing. On the return, because the duct is lower pressure than the air around it, if the seals aren't great and you didn't line up the backing plate and you didn't really get the gasket on, the leaks are going in around your humidifier, so you don't really see them. Likewise, you're not going to blow it off the duct. Poking holes in return duct, pretty easy, pretty cheap. A lot of times people will suggest that you use a water-tolerant material. So instead of galvanized or steel duct, they'll tell you to use something more like aluminum or stainless steel. That's fine. If you're doing this yourself specifically, I would just put it in the steel and then check the steel once a month to see how bad it's getting. If it's not getting bad, then I would leave it. Yeah, it could rust out. And then you replace the steel with the aluminum like they told you to do when you first did it. If you want to do this in one shot and you want to pay a guy and never see him again, sure, go ahead and have him buy a couple feet of aluminum duct so that if this does drip, if it does spatter or whatever, that you then have a nice aluminum duct that's not going to rust. It's just going to have the moisture sit on it so it goes away. that's about it. The big concern with adding humidity is the dew point. So with your dew point in your space, depending on your relative humidity, you can look at a psychrometric chart to figure this out, or you can get a swing cyclometer, which basically just puts a wet paper towel on a thermometer and you can shake it back and forth and figure out what the wet bulb temperature is. So whatever temperature that thermometer gets to by shaking it around with a wet end, that's going to be your wet bulb temperature, and that's going to be the dew point. So on a dry day in winter, it's probably not a bad temperature. It's probably in the 30s or 40s. The problem you're going to have is if you're adding a lot of moisture to your house. If your house is, say, 70 degrees and like 50% relative humidity, your dew point is going to be like 55 or so. Well, 55 when it's really cold outside is not hard to hit. So whatever surfaces in your house are 55 degrees, if they're getting active, conditioned, humidified air past them, you're going to get condensation. Most of the time, this is just on like windows, sills, edges of the sashes. Normally you can kind of figure out like, oh, well, that window gets it because either the airflow pattern in the house or something silly like the shielding gas isn't good anymore, or it's your oldest window in your house and it's not as, insulative as the rest of them. The concern would be my first house. I had a chunk of wall that wasn't insulated properly. So when it was like 0 degrees outside, it was probably about 25 or 30 in my attic, and the wall between the bedroom and the attic would probably be on the edge of like 40, 50 degrees. So we would get drips on that wall, and if those drips are getting into the wall, then you can get water damage from things like that. If you have a weird floor, like an overhang, sometimes those floor surfaces will get really cold and you can get condensation on those. And then the normal one is something like a weird pipe that is someplace it shouldn't be. And because of that, it's either like a vent that goes outside, something the cable guy did, and you now have a cold pipe that comes into conditioned space. That's a frequent place to get moisture if you're humidifying. So those would be the things to look out for if you're adding humidity to the space in a not so modern house. So there you go. That was the quick sermon that I gave my buddy. Now it's here for all. So if you have questions, feel free to reach out. addingenergy@gmail.com. We're Adding Energy on Twitter, or drop a note on the website. If you have questions, you can even comment below if you're watching the video, or give us a shout out through whatever source you like. I am Brian McLean for the Adding Energy podcast. Thanks for giving a watt.